Morning, everybody. This is a little quick fuel injection slash engine performance primer I put together, and it was one I had done for my students several years ago. But it's I've updated it, cleared up the images a little bit, and hopefully you'll get something out of this. But one of the things that whenever I was doing student recruiting when I was running that automotive program for all those years, the guy that ran the welding department, he was as a guy that would build hot rods and stuff like that, you know, which was fine. But what was interesting to me was whenever these groups of students that were coming from high school, they came over on buses, they would tour the campus, and when they went by the welding department, they'd see these shiny hot rods over there and all that kind of thing. And then when they'd come around to where we were, we would have a bunch of cars in there that we were working on, like vans and SUVs and stuff, replacing transmissions and working on engines and stuff like that. And I would ask them, I'd say, did you see a bunch of shiny hot rods over there at the welding department? And they'd say, yeah. And I says, well, we don't have time to fool with that. We're here to fix cars. And I told another one of my students that liked to stay home and skip class and work on his hot rod drag car. And I says, what you're doing is not mechanic work whenever you're working on your drag car. I said, what are you talking about? And I says, which way is the money flowing? He was spending his mother's money on his hot rod instead of money flowing in his direction, working on other people's cars, doing regular work for cars that drive up and down the road every day and take people from point A to point B. Well, a machine that breathes is what the engine is, and you got 14.5 psi at sea level. Going through the air filter, the air comes in, it goes through the plenum. The reason there's a plenum is every cylinder has to get exactly the same amount of air. So it's got to be pressurized in here so that there won't be one cylinder getting any more than others. Same with EGR. You'll typically have EGR putting its gas in here, or it'll have a separate port for each cylinder so that they'll make sure that every cylinder gets an equal amount of everything, including fuel and that kind of thing. And there's a little bit of a caveat there on the newer stuff, you know, with your gasoline direct injection. You know, whenever you got something that's really fine-tuned in those engine performance algorithms, it may be able to put less fuel in one particular cylinder if it feels like it needs to. But typically it just does that from one bank to the other, because it's got two oxygen sensors, one on each bank, and if one bank is running richer than the other, it'll put more on that bank than this one anyway, so on and so forth. But it converts power to motion to get work done. That's what an engine is supposed to do anyway. It combines air and fuel to generate force. Atmosphere, 78% nitrogen, 21% oxygen, and 1% of other stuff. Alright, so it goes to the transmission, the final drive, and then you get green-friendly CO2. Notice how the grass is growing on the side of the highway, has to be cut a lot. If this car exhaust was as bad as they're trying to act like, you know, of course they're saying, well, it's going up. Well, CO2 is, the atomic weight of CO2 is 44, which means it stays close to the ground anyway. Of course, air circulates and all that kind of thing. But one way or another, there's other stuff I could talk about that, but I'm not here to talk about CO2. On a naturally aspirated engine, what causes the air to enter the intake to begin with? What's the basic principle that does that? That's just a question for thought. All right, you're breathing and you're working with that thing. This is a cylinder pressure waveform down here. You've seen these all over the place if you've been, you know, in the circles that mechanics use it now. Interestingly enough, my experience has been, and it may have changed, but this is typically something you'll see them doing at independent shops more than you will at dealerships. But there's probably some dealerships that are using waveforms too. You get a pressure transducer and put it in, you know, pull one plug out, put it in there, and you fire it up, and this is basically your intake, your compression, your power, and the exhaust. You see that goes up a little because it's pushing the exhaust gas out, and then it pulls pulls it back down. This is basically atmospheric pressure down here. All right, so then you got compression, combustion, and then your power stroke and your exhaust and so on and so forth. I hope that, you know, it's a little quickie there. And this is basically the stuff it's looking at on whenever GM started using mass airflow sensors, you know, the ones with the heated wires in them, back in the mid-1980s. and they also put coil pack ignition on them back then. But you know, they were sort of a cutting edge deal on that. The mass airflow was on there, but they didn't have MAP. Well, they started giving trouble. The mass airflow started giving trouble, and so GM had a retrofit and had you come back and put a MAP in there, MAP sensor in it as a backup. Then you got a throttle position sensor. It needs to know how fast you're moving the throttle. It needs to know whether you're moving the throttle. It needs to know if it's at idle. It needs to know if it's at wide open throttle, and anywhere in between. That's an analog input, by the way. Your cam position sensor and crank position sensor. Typically, you'll only have a cam position sensor if the fuel injection is sequential. Now, that being said, the profile ignition pickup cup in the older Ford fuel injected systems, it was in there even though they were bank fired, you know, until 1986, whenever the Crown Victoria came out with sequential injection and all that. Tempos didn't get a cam position sensor until they went sequential injection I think it was in 1992. All right, so anyway, but sequential injection fires the injectors in following the firing order, and as you know, and then whatever the firing order is, the injector will fire that. But there's a caveat here, and I'm going to show you that in just a minute in a little video I got. Early atomizing, you know, the carburetor was the way they did this to start with. Now, there were some carburetors, like on your old tractors and stuff, there were updraft carburetors. They have a carburetor down on the bottom pulling air up into the intake, and they are side draft carburetors that pull it in from the side, like on some of your Euro platforms. And then there, most of the ones that we were familiar with were these downdraft carburetors, where you know, this is the choke, and then they're showing the choke partially closed here, but typically it'll be straight up and down. And because you've got atmospheric pressure here pressing down on the fuel, and you've got this venturi here, the air picks up speed going through here and the pressure gets lower, it draws fuel through this jet. And here you can write books on carburation, but the long and the short of it is, this is basically what a carburetor does. And whenever this is closed, there's another, I could have put a diagram on that here too, but we're not really talking about carburetors today. But whenever the throttle plate's closed, there's another little passage that goes through the idle, you know, where the idle screw is, where you set the idle mixture. That's where it gets the fuel that it burns when it's idling, and you can adjust that to make it idle smooth. But this is showing the throttle valve partially open, so you got air going through that venturi and it picks up speed. You got a primary venturi and a secondary venturi, you know, that's kind of, but anyway, it's got to be atomized, and the finer it's atomized, the better it works. You remember I told you, or I may or may not have, I put a screen under the carburetor on a 74 F100 that I had. Put a real fine stainless steel screen under there. And there were actually gaskets you could get with little screens built into the gasket that had a sort of bulbous so that the throttle plate would miss them. And that was supposed to bust up the fuel better. But fuel injection atomizes the fuel better than a carburetor and gives less trouble over time. You know, I worked on carburetors for years and years and years, for decades, and the people that loved carburetors as much as they did didn't factor in that fuel injection, like the fuel injection vehicles that I've had to do almost nothing to. The last vehicle I had that was a daily driver that had a carburetor on it was a Nissan Sentra that was an 87 model. And that thing put me down beside the road more than any other vehicle I ever had. There was a little screen in that carburetor in that Nissan that you couldn't see, and you didn't know was there unless you knew it was there, and it would clog up and starve that thing for fuel. That happened to me on a trip to Savannah, and I had to figure out what was going on. It was starving for fuel and hardly run, and so whenever I pulled the hose off going up in there and screwed that little fitting out, I had to take my test light and poke a hole in that screen so the carburetor could get fuel. Well, the fuel pump died on that one too. One of the little check valves came apart in it, and so I'd crank that one up and I'd drive about 100 yards, and then it would stall. Then you'd spin it, spin it, spin it, spin it, spin it, it would start up, then you'd drive okay till the next time you parked it started hot. I've seen that on those. But anytime I had either a diesel or a fuel injected vehicle, I would drive it for a long way and hardly have any trouble with it at all. Now, if you're not familiar with fuel injection, you won't like it if you have to figure out what's wrong with one, and a lot of the older mechanics did that. Well, throttle body injection came out first. On these Fords, you typically had 40 pounds of pressure regulated here. You notice there's no vacuum line here because the injectors were spraying above the throttle plates. In other words, so you didn't have to try to equalize the pressure at the tip of the injector by putting a vacuum line going to the pressure regulator. But when that fuel pressure came in, it had a calibrated spring here. You could actually adjust it. You might notice they have a little adjustment screw there, but most of the time, one Chrysler instructor says you can take a socket and whack that thing and change the pressure a little bit. But anyway, whenever this pressure would go on against this diaphragm, it would raise it up. And this is basically a pressure regulator. If the pressure regulator was wide open, then you wouldn't have enough pressure. If it was stuck shut, like for some reason the spring was rusted and the valve and all that, you'd have like 100 pounds of pressure, and it would make it run rich and all that kind of thing. Well, the pressure that was excess would go back to the gas tank right there. A lot of these other earlier vehicles had a resistor in line with the drop in the voltage going to the fuel pump, so that the fuel pump wouldn't be quite so noisy. That was something that they did there. Alright, now this kind of system appeared on some of the vehicles in the late 70s in various configurations. GM and Chrysler had their throttle body injection, which was similar to this. The injectors looked different. They had little O-rings around them, they go down in here, and that kind of thing. We worked on a 91 Chevy one time. This guy had bought a engine from Parts House, put it in there, and he kind of knew how to put an engine in there. It was a 350, and he put it in his 91 Chevy pickup, and it had throttle body injection like this, and the thing would not run right. It wouldn't idle right, and he was just real disappointed in it. So he brought it to us, and what we found out was he didn't adjust the valves. Just because you bought the engine from the parts store doesn't mean you don't need to adjust the valves on a small block Chevy. So we adjusted the valves, and it ran a whole lot better, but it still had a little bit of a rough idle to it. And I had a bunch of engine controllers laying around. They had those little, ROM chips in them that you had to change out on the older GM computer command control and early throttle body. And I kept swapping out these little, there's a little calibration pack too, that the little centipede thing. And I kept changing those out and changing those out from one to another, and finally putting one in there that made that thing run so smooth. And oddly enough, it was one from a V6. It's mind-boggling, but anyway, I made that thing run good by doing that. But anyway, this throttle body stuff on the GM vehicles, this throttle body injection only had about 12 pounds of pressure. If the fuel filter stops up on one of those, it'll feel like the catalytic converter's clogged up. Well, on the Chrysler and on some of the Fords that had a throttle body, like I guess on the 4 cylinders that had a throttle body injector very similar to this, they would run 40 pounds of pressure. And so there you go. And they also begin to have adaptive learning on these right here. When you got an oxygen sensor, you got fuel injector, and then so they had what we now call long and short fuel trim. They used to call block learn and integrator. Integrator would be the immediate adjustment. Block learn would be the overall, like long fuel trim. So think of integrator as short fuel trim and block learn as long fuel trim. And that was an interesting little thing there. Port fuel injection had one nozzle per cylinder, and I cleaned these things up for you a little bit. There are returnless systems, where you got a fuel pump driver module and all that. I talked about that before. And but anyway, this is a fuel. This right here is the place where the fuel pressure regulator goes. They didn't picture that in here, and I actually retooled this from a shop manual drawing I had. This right here is a pulsation damper. That pulsation damper keeps you from hearing the injectors clicking. They basically want the engine to be quiet. They don't want to hear click, 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 with the lines bouncing against the frame when the injectors are clicking and all that. Because there is some pulsation in there whenever the injectors are opening and closing, and then they put that pulsation damper. It'll either be on right there, or it'll be sometimes it'll be mounted on a sort of a pipe or a hose sticking out to the side, but usually it's mounted right on the fuel rail. And you'll also see similar stuff like this on a gasoline direct injection.
The fuel injectors
Watch
when you
this.
first start, and then what they do after you pick up some speed. accelerator pump on a carburetor that they've used. Notice you've got to pat that accelerator to wet the manifold, and that's what that simultaneous pulse is all about. If you have one that's not simultaneous pulsing for some reason, like if it doesn't know you're in start, then the problem you'll have will be a hard start. Although when it does start, it will run pretty good. I've seen this before. Just wanted to pass this along.
Couple of things about that. I built this board so that the students could actually wire up a fuel injection system from the, it had an engine controller in there and all that, and you notice it had a wheel mounted on a, basically it was on a fan motor, and I actually put some resistors in there to slow the fan motor down so that it didn't just start spinning really fast. And it would fire the, it was cool on that because you could turn that thing through by hand and it didn't start firing the coils until it saw that missing tooth pass a second time, which was very instructive too. But you might have noticed that the injectors started firing all at the same time, and then they started firing sequentially. This was, believe it or not, from a '98 Explorer. There was one of the maintenance men had a daughter that wrecked one, and he told me I could have anything off of it I wanted because it was sitting out there on his property. And I sent my students out there, and they brought me the wire, the engine controller. They brought me the, all of the stuff. And I actually I had a fan blowing through the throttle body so it would see mass airflow. You could plug the scan tool in right here, and you could actually operate the throttle and watch the pulse width expand on the injectors. There was all kinds of cool stuff you could do with this. And it was pretty easy to wire up because everything would tell you which pin, which processor pin was on there. But they had to wire up the data communication link. They had to wire up everything that was on this board. They had to wire it up. And then whenever you would turn that key, it would start spinning that thing. One time I was standing next to this thing talking while it was running, and I was standing there and the coils were firing up there, the coil pack that I had on this thing. And I started getting kind of lightheaded, and I thought, why am I feeling lightheaded here? And I realized that those sparks that were popping, and they were jumping about an inch, walking up and down that coil pack. They were making ozone, and I was breathing ozone, and I was getting lightheaded because I was kind of getting oxygen drunk. I never thought about that until it happened to me the first time. Basic injection principle is you got a crank sensor, the PCM, and injectors, and the frequency of the injectors firing is determined by the crank position sensor. If you listen to the injectors, they'll go click, 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 and then whenever the engine picks up speed, they'll click, 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 they'll fire faster. The timing of their firing is determined by the cam sensor. That way it knows which injector to fire first. So basically, if on some of these vehicles, like on a Nissan Altima, the way I understand it, if you unplug the cam sensor on a Nissan Altima or on a Jeep Wrangler for that, Jeep Cherokee, the old 4-liter, you unplug the cam sensor on I'm talking about the 87 to 90 models that had the Bendix fuel injection, not the ones after that had Chrysler fuel injection. But if you unplug the cam sensor, it wouldn't know which injector to fire first. And it was, on the Altima, if you unplug the cam sensor on like a 2000s vintage Altima, it may start and it may not. That's what's so crazy about that is you may have a no start, and then the next time you try to start it, switch it off and it may fire right up. And if it's got two cam sensors, one in each bank, and one of them's not working, it'll start hard. It'll boom, 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 and it'll fire up. We had one that burned up a starter because of that the guy brought it in, and I noticed it was spinning a long time before it started. We got a cam sensor code, popped the cam sensor in the one that wasn't working, and it was breathe on it, the key was running. Pulse width, which is the amount of time the injectors are open, is determined by other sensors which measure engine load, airflow, manifold pressure. They also measure temperature of the incoming air and coolant, throttle action, so on and so forth. The pulse width is affected by a lot of stuff. Alright, so it's wired basically like that, so you're getting most of the time, the only other vehicle I know that actually has the injectors hardwired to ground and powers them up from the engine controller is the 87 to 90 Jeep Cherokee 4-liters. But every other vehicle, including the one that's drawn here, you're getting the relay powers up the injectors, and then they're getting their marching orders from the engine controller based on its inputs. Injector on time is represented here. When the injector is not on, you're seeing the 12 volts is coming all the way through here. This is going to have 12 volts until the engine controller pulls it to ground, and the amount of time it's pulled to ground is represented by this little bucket here. If you're ever watching a scope and you operate the throttle, you'll see this move. It'll get this thing here move over. That spike is an inductive spike that happens when you remove the voltage from the injector. It's about 30 to 50 volts usually, and that's normal. You're going to see that, and it's the system designed to handle that. But anyway, there's your injector on time right there, so remember that. But this is where you connect your scope. It's pretty simple. You go between ground and here with your scope, and you got to set up your time, all that, time and voltage and all that kind of thing to see this, because this is in milliseconds. This is very, when it's cold, this will be wider. When it's starting, all of these injectors will be clicking at the same time, and then when it fires up, they'll start firing, following the firing order, and so on and so forth. All right. The art of war. Sun Tzu says, know your enemy. Well, the customer is not your enemy. The vehicle is not your enemy. The customer's concern is your enemy. To defeat that enemy, you got to gather intel. All right. Some rules hadn't changed. Whether carburetor or fuel injected, these apply. The engine needs the proper amount of extra fuel on the first cold start, but not too much. That's why it fires all the injectors at the same time. We had one time that I talked about that was had been at a shop in a town over there somewhere, and the guy had changed the engine controller and everything else. It would start really, really hard when it was cold, and he couldn't figure out why. And it turned out it had a blown fuse, so that the engine controller didn't know you were in the start position, and it wasn't firing all the injectors at the same time. It was firing them sequentially when you were trying to start it. That wasn't enough fuel for it to start unless you spun it for a while. And so we basically, just to fix that one, all we had to do was put a fuse in there. Somebody had actually pulled a fuse out and put it in there for the radio or something, and when we found that fuse missing, I think it was fuse number 21 on that 97, whatever it was an Asian car. Anyway, put a fuse in there, boom, that's all it took. A cold engine needs more fuel in the mix than a warm engine, which means that it's going to have a wider pulse width when it's cold, and also something that can skew that. If you've got like a Dodge or something or any of them that will substitute a value if you want to see a problem, unplug the intake air temperature sensor on a cold day, right? You unplug the intake air temperature sensor, it's going to substitute 101 degrees Fahrenheit on like a Dodge. If it's 40 degrees outside and you unplug that intake air temperature sensor, it's going to wet the plugs. Just as simple as that. If you have one that is flex fuel and it's over-reporting the alcohol, if there's no alcohol in the fuel, or 10% or less, and it's telling you there's 40% in there on one of these Chevys, it will overfuel when it's cold and foul the plug sometimes when you're trying to start it. However, I found out on my Betty's Chevrolet that you can go in there with your scan tool, if you got a good scan tool, and you can reset that flex fuel sensor instead of having to replace it every time. So you might try that before you buy, $500, $600, $700 sensor to pop on there. Too much fuel will give you black smoke, which is lots of hydrocarbons, or a no start and wet spark plugs, like this. PCM depends on sensor inputs to make fuel calculations. High fuel pressure, a saturated canister, a stuck open injector, a ruptured fuel pressure regulator diaphragm can deliver too much fuel. This right here was an actual Jeep I had that had a fuel injector stuck open that I worked on. It was blowing this misty cloud. This wasn't black smoke. This was liquid fuel that was coming out. You could hold your hand down there and it went with gasoline. Now, on the older ones, when the oxygen sensor would, you'd have a loss of the oxygen sensor signal on older vehicles, it would make it start puff a bunch of black smoke because it would, it wouldn't know, it couldn't trust the oxygen sensor, and it would just start pumping fuel in there. But I had a Cadillac Escalade that came in, and the lady came in there and she says it had a traction control light, and we pulled the codes and it gave a network code. Well, we weren't fooling with that at that particular semester, and I said, take this over to the Cadillac place. They're probably going to have a reflash for this or something, or but we don't have time to fool with chasing a network code problem. So she takes to the Cadillac place. She comes back and she says, they tell me that it needs a fuel pump and it's going to be like, $1,800. And I said, good grief. And so I checked the fuel pressure, and it had massive, incredible amounts of fuel pressure. Gosh, I can't remember, but it seemed like it was like 160 pounds of fuel pressure. Now the fuel pump on that one has got a regulator built into the tank. It's a returnless fuel system, but it's regulated in the tank with an old-fashioned regulator. And so for $450, we got her a fuel pump put in there. Now the thing wasn't running bad. The only symptom she had was that traction control light, which was mind-boggling to me, because usually when you got too much fuel pressure, it's running rich. So after we got the fuel pump replaced, the pressure went back down around 60, 70 pounds, whatever it's supposed to be. The traction control light went away. The network code went away. She didn't have any kind of an engine code. It's just totally astonishing to me. I wish I could reason all this stuff out, and somebody else is more familiar with those Cadillacs might be able to tell you why, but that's what we found on that one. We replaced the fuel pump to get rid of a traction control light and and a network code. Duh. Atomizing, though, is everything. Fuel burns more efficiently the more finely it's atomized. So the smaller the droplets, the better the burn. That's why carburetors gave way to fuel injection in the first place, and that's why GDI, fuel injection, is replacing the older EFI. Engine controller got more control. They wanted to control the fuel better. EFI does that better than a carburetor. Some of your feedback carburetors on General Motors, they had a little solenoid that would click up and down 10 times a second going down into that metering thing. And if it was down, it was lean. If it was up, it was running a little rich. That was only a slight change it could make. Some of your Fords and other would actually have an air bleed. Some of the Jeeps and your Fords and all on feedback carburetors. Well, they wanted to control the fuel better instead of just tweaking the mix. So they basically put fuel injection on it. So you got electronic fuel injection. You got better control of that. Except on your Volkswagen KJ-tronic stuff, which is weird. I'll have to talk about that another time. Gasoline direct injection has several different ways it can squirt the fuel directly into the cylinder instead of having it behind the intake valve like the other ones. Only problem with that is when you're spraying it directly in here, it tends to build crud on the intake valve, the same oil steam that causes the throttle plate to get messed up and all gets on the back of the valve and clogs that up. So some of the Fords and Toyotas, and possibly some of the other ones I don't know about, have added they've got injectors in here where they used to be. They've also got gasoline direct injectors. The strategy of using those is different, but they did that to keep the valves from getting so messed up. And so they had to actually write some different algorithms and add some more injectors and a secondary fuel system and all that. I don't know if you were familiar with that. But look at the size of these droplets. 100 microns on a carburetor, 10 to 50 on a PF port fuel injection, and 5 to 20 on the, that is just something else, how that is. And also you have on a gasoline direct injection, you got a stratified charge, you got a homogeneous charge, you got a stratified / homogeneous. I mean, there's a bunch of stuff. I wrote a course for Cars on Demand about gasoline direct injection, and I talked about that in there. Window into the system, Donnie was working on this. I mentioned this one before, but it was funny. Runs rich when you first start it, puffs black smoke till it warms up. He said if it had data stream, I could do a lot more with it. Well, see this one here. He said it's not the diagnostic trouble codes. I don't even think he was getting any codes. And it was, because see, this was only happening when it was an open loop. So it was this Ford Limbo around 1990 where it may or may not have a data stream. Some of them had a data stream, some of them didn't. So he was used to having a data stream. Now if a 1990 Ford vehicle has an E4OD transmission, if it's one of these V8s, and or mass airflow on any of them, it will have a data stream. Mustang broke the rule because Mustang's got mass airflow in 1989 but didn't get data stream until 1994. So you wouldn't have any data stream to where you could look at the window into the system before 1994 on the Mustang, even though they got mass airflow in 1989. But everything else, if it had mass airflow, they had typed up those algorithms to give you data stream. Well, you got to get into the PCM's head if you're wanting to see a lot of the stuff that you can't measure with a scope. For example, you cannot measure fuel trim with a scope or a voltmeter or anything else. Basically, you're stuck with having to just sort of figure things out the old-fashioned way. And I've done that too. I have actually had one that was running kind of rich, and you could, from Ellen Smith at General Motors School in 1981, and whenever I went up there in 1982, whenever it was, you could take the your hand, your fingers, and you could touch the battery cable and touch the oxygen sensor lead, unplug it from the oxygen sensor, touch it, and tap it with your finger and all. And if that black smoke went away, you knew you had an oxygen sensor problem. That was before the days of data stream. I could talk about that some more. But a scope is necessary, but the scan tool is an easy first step if the BCM's in a talking booth. We all plug our scan tools in before we get our scope out, okay? All right. So I checked the OBD1 connector on they call that the VIP test connector on the Fords. And so I noticed that it had these two leads here, and it had the twisted pair going in there. I said, there's your data stream right there. He said, well, it won't give me that data stream. I said, well, lie to it and tell it you got an E4OD transmission. So he said, it doesn't matter. He lied to it, told it it had an E4OD transmission when it didn't, and he got data stream. All right, now I had never seen an AOD equipped vehicle with data stream capabilities, but you know, sometimes they do stuff. If the wire's there, the data stream is there. That's not always the way it is, but that's the way it was on this one here. Okay, so he did what I said. There was the data stream. Now sometimes the scan tool doesn't work. We need to gather data the old-fashioned way. A lot of people have the idea that some of these young bucks have the idea that you can do anything, that all there is to fixing cars is plugging in a scan tool, getting the code, changing a sensor, and then you're done. Well, that's a bunch of hooey. Sometimes that's the way it is, but most of the time it's not. This thing got a floating TP signal. What we found was the TP sensor voltage was waggling around just above closed throttle right after engine start, even though nobody was touching the gas. And it was putting a bunch of extra injector squirts in there, because that's like the accelerator pump on a carburetor. And all those extra injector shots it was getting, it felt like somebody was feathering the gas. And so it kept putting those in. That's where that black smoke was coming from. With a TP sensor on that thing, straightened it right out. Well, this was an in-range failure, so it didn't throw him a code for a TP sensor. And his lack of a diagnostic code was troublesome and misleading. So knowing TP voltage changes can cause the injector to deliver extra pulses was key to understanding this issue. That's why it's important to understand how and why fuel injection does the things it does. There's a lot of stuff, though, that they don't write in a book, and you just have to learn it the hard way. Well, that winds us up today. And hot rods are fun. I wasn't speaking against them necessarily, but basically what we do in the service bay is we fix cars that people drive to work every day and that soccer moms take their kids to practice on. I'll see you guys next time. We've been here 32 minutes. Hope you lasted till the end. Next week, fellas.